Hello everyone, in this video we are going to solve the Leetcode question number 1277, Count Square Submatrix with all 1. The question is given an m cross n matrix of ones and zeros. Return how many square submatrix have all ones. We are given 2 examples in the question. In the first example, our matrix has 3 rows and 4 columns. In this matrix, each one is a 1 cross 1 square. For example, this is a square, and this is a square, and this is a square. Each one is of 1 cross 1 square. And we have 4 2 cross 2 square. Here is 1 square, and here is the second square, and here is the third square, and here is the fourth square. And we have 1 3 cross 3 square. So in total we have 15 squares. Hence we are returning the output as 15. In our next example, we have 3 rows and 3 columns. In this matrix we have 6 ones. So we have 6 1 cross 1 squares, and we have 1 2 cross 2 square. So 6 plus 1 is 7. So we have 7 square in this matrix. I hope the question is clear. Now let's get into the approach. Let's take an example of this matrix which has 3 rows and 4 columns. We are going to solve this using dynamic programming approach. As a first step, we will create a DP table of same size, and we will initialize to 0. In each cell of the DP array, we will store the largest square submatrix of 1 that ends at that position. At first, we are initializing it to 0. For the first row and the first column, the DP values are same as the input matrix, because we can only form 1 cross 1 squares here. Let's start with the first row of the matrix. Since there is no cell above it, the DP values here will be exactly the same as the matrix. That means each one represents 1 cross 1 matrix. We can form 1 cross 1 matrix here, 1 cross 1 matrix, and another 1 cross 1 matrix. 0 means there is no square. Now let's iterate over the second row of the matrix. For the second row first column, we can have only 1 cross 1 square. So we will have 1 in our DP array. From the next cell, if there is 1, we will check all 3 sides of the DP array. We will check the left side, diagonal, and top. And we will take the minimum of all 3 plus 1. So 1 plus 0 equals to 1. We will move on to the next cell. Our next cell is also 1. So we are seeing all 3 sides of the DP array, and we will take the minimum. The minimum is 1, and we will add 1 to the minimum. So 1 plus 1 makes 2. The next cell is also 1. So we will check all 3 sides of the DP array, and we will take the minimum. The minimum value is 1. So 1 plus 1 makes 2. Now we will iterate through the third row. The first value is a 0, so we don't have to do anything. The second value is 1. So we will take the minimum of all 3 sides. The minimum of all these 3 sides is 0. So 0 plus 1 is 1. Now we will move on to the next cell. The element is 1. So we will check the minimum of all these 3 sides. The minimum of all these 3 sides is 1. So we will add 1. 1 plus 1 makes 2. We will add 2 to this cell. The last element is also 1. So the minimum of all the 3 sides is 2. So we will add 1 to the minimum element. 2 plus 1 makes 3. Now we will add all the elements of the DP array, and we will return that as our output. So 3 plus 6 plus 6 is 15. We are returning the output as 15. I hope the approach is clear. Now let's get into the implementation. First we will start with the edge case. If our matrix has no rows, we can immediately return 0. If not matrix or not matrix of 0, we can return 0. Next, we will find the number of rows and the columns of the matrix. I will assign to the variable m and n equal to length of matrix. This is the number of rows and the number of columns. Length of matrix of 0. This is the number of columns. Now we will form the DP array. DP equals to list of list. We will initialize it to 0 times the number of columns, which is n, for I in range of number of rows. We are forming the DP array of the size of the matrix. Now we will iterate through each cell for R in range of m, for C in range of n. We will perform some operation only when the cell has 1. If matrix of R of C equals to 1, if it is a first row or the first column of the matrix, we will mention the DP cell as 1. If R equals to 0 or C equals to 0, then DP of R of C equals to 1. If it is not the first row, else DP of R of C equals to 1 plus min of all the 3 sides, which is DP of R minus 1 of C, comma, the previous column DP of R C minus 1, or the diagonal DP of R minus 1 of C minus 1. At the end, we will find the sum of all the elements of the DP array. Return sum of row for row in DP. We are taking the sum of all the row and taking the sum of all the columns. That's pretty much it. Now let's submit it. Our solution got accepted. I hope you like this video and I'm sure that you learned something new today. If you do like this video, please consider to subscribe and I will see you in yet another interesting Leetcode interview question. Thank you.